Welcome to Get Your FRQ On. This is question 4 from 2017, and it is not calculator active. In the question stem, we have a potato being removed from boiling water. The internal temperature of the potato when it is removed from the boiling water is 91 degrees Celsius, and the temperature of the internal temperature of the potato can be modeled by a function h that satisfies a given differential equation, dh dt. In part A of the question, we are asked to write the equation for the tangent line to the function h at t equals 0 and use it to approximate h of 3. All right, we're given in the question stem that dh dt is negative 1/4 h minus 27 and that h of 0 is equal to 91. So if I plug in 0 for really nothing, but 91 in for h of 0, then dh dt at 0 comma 91 would be negative 1/4 of whatever 91 minus 27 is, which happens to be 64. Negative 1/4 of 64 is negative 16 degrees Celsius. So that would be the slope of our tangent line at t equals 0. And since I already know that the y-coordinate there, or the h-coordinate there, is 91, I can write this equation for the tangent line as y minus 91 equals negative 16t, which is the same as y equals negative 16t plus 91. And if I want to use that equation to approximate h of t, I'm just going to plug h of 3, I'm just going to plug 3 in for t. And negative 16 times 3 is negative 48. Negative 48 plus 91 is 43 degrees Celsius. So at t equals 3, the internal temperature of the potato is about 43 degrees Celsius. In part B of the question, we are asked to find d squared h dt squared and determine if h of 3 from the previous part is an over or an underestimate for the real value of h of 3. All right, so we can actually find d squared h dt squared by differentiating dh dt. When we do that, we get the derivative of negative 1/4 h minus 27, which just turns out to be positive 1/16 h minus 27. All right, so that's the second derivative. This is going to tell us about the concavity of h. Now, because we're also given in the question stem that the internal temperature of the potato is more than 27 degrees for all values of t greater than 0, the h in this equation will always be bigger than 27, and so when we subtract 27 from it, it's always going to be positive. So the factor h minus 27 is always going to be positive, and the 1/16 is always positive. Positive times positive is positive, which means this is concave up, and so our tangent line will be below the actual curve. So our approximation in part A should be an underestimate for the actual value of h of 3. In part C of this question, we are given a function which satisfies the differential equation d of g dt is equal to negative g minus 27 to the 2/3 power, and that g of 0 is 91, and we are to find a function g of t that satisfies this differential equation and use it to evaluate g of 3. All right, so we have the differential equation. It's AB, so really the only method we have for solving differential equations like this is separation of variables, so we're going to have to separate variables. All right, so divide both sides by g minus 27 to the 2/3, multiply both sides by dt, anti-differentiate both sides, and we get 3 times g minus 27 to the 1/3 equals negative t plus c. Now we can use the initial condition that g of 0 equals 91 to solve for a specific value of c. So if I plug in 91 for g, 0 for t, we get that c is equal to 12. All right, and this allows us to write the particular solution using c equals 12. All right, so we have 3 times g minus 27 to the 1/3 equals negative t plus 12. Solving for g here, we would have to divide negative t plus 12 by 3, then cube it, then add 27. So g of t is this function or something equivalent to it. You don't have to have exactly that expression, but you would have to have an expression which is equivalent to this. And then to approximate g of 3, we're just going to plug in 3 for t. And negative 3 plus 12 is 9. 9 over 3 is 3. 3 cubed is 27. 27 plus 27 is 54. So if this is the function that models the internal temperature of the potato, then the internal temperature of the potato at t equals 3 would be 54 degrees Celsius.